we are. Question 1. Projectile is fired from a point in the horizontal plane with an initial velocity of 21I and 28J. Its height above the plane find after 3 seconds. Okay, so just write this is question 1, part 1, and we're told that it is traveling at 21I and 28J, and that's meters per second. Right, so what does that mean? That means that it travels initially up with a velocity of 28, and it travels this way with a velocity of 21. So that actually would give us the direction, if we wanted it, that it travels in. We don't need that. So this travels as a projectile, like so. So this means that because the up direction is positive, we're going to set that up, and we'll always do that. The down velocity, the acceleration, minus g is down. Now, that means that at every point along this, it will have a velocity, particular velocity, all the way along. And here we'll say that's the end point, that's symmetric. Now, so its vertical velocity, because of gravity, it's changing its velocity. It's accelerating, it's decelerating, getting slower. So here it will have less velocity, and here even less again, and a tiny bit. And actually at the top, the velocity in the vertically will be 0. And when it gets to here, then it will start to come back down again at every point. I'm just drawing in a few of those points. And this one here actually will be minus 28, because the other one's 28. So when it lands again on the ground at the same height, presuming that is the same height, just there. So we have to realize that the two velocities are independent. The horizontal and vertical velocities are independent. Totally independent of each other, and that's the key idea. Right, so with these, we want to find out what the height is after just 3 seconds. So if this fires up in the air after 3 seconds, what's the height? So we know this here is the t equal to 0, that's fine. So U, V, A, S, and T, always list them, okay? So list what we know. Now the U, this is the velocity in the y direction. It's the final velocity in the y direction, acceleration in the y direction, and distance in the y direction, or displacement. So so that means we don't put a u, an x, or a y on t. We don't say the distance in the time in the x direction or time in the y, because time is actually a scalar, unlike all of these, which are all vectors. So time doesn't have doesn't have direction. It's just a scalar. Okay, so that's why I didn't put a y on that. It wouldn't make any sense. So the initial velocity in the y direction is 28. The final velocity after 3 seconds, we don't know. We know the acceleration is always 9.8 meters, minus 9.8. The distance is actually what we're looking for, and we know it travels for 3 seconds. So we'll use the equations of motion, which of course are v equals u plus at, v squared equals u squared plus 2as, and s equals ut plus a half at squared. Now the interesting thing about these equations is this one here, in terms of these 5 quantities, has no distance, has no s in it. That one's lacking s. This one here has no t in it, and this one has no v in it. So in this here, in these 4 quantities that we're looking for, if we get rid of v, we don't care about v, so that's why I'm going to use this equation. So first thing you do is you list the quantities you have, then choose the equation. So we're going to use s equals ut plus a half at squared. Important that you always write the equation out, just like that. Don't fill in anything. Just write the equation on its own so that you can show the examiner exactly which equation you used. So then fill them in. So sy equals u, which is 28, times t, which is 3, plus half of minus 9.8, half 9.8, times 3 squared. Okay, that's a 3. Doesn't look like a 3. That's 3 squared. And write in all the numbers before you do any calculations. Don't write 3 squared is 9. You might know that, but don't write it in. Right, so next up then, s of y, to start the calculations. 28 times 3 is, of course, 84. 84 minus half of 98 is 4.9, and then that has to also be multiplied by 9. Then s of y is equal to 84 minus 4.9 by 9 is 44.1. So s of y ends up equaling 39.9. Then it's really important that you put the units in, and that is 39.9. So that means after 3 seconds, the height will be 39.9 meters. But what's important to realize is that the horizontal velocity, remember, is constant. It's always the same. It never changes because there's no force in that direction. So that's always the same, okay? Always 21. And that means that this thing traveling up and traveling back down is independent of this horizontal velocity. So if it was fired up at 28 meters per second, after 3 seconds, it reaches a height of 39.9 meters per second, meters. But it doesn't matter what this horizontal velocity is. In fact, if there was no horizontal velocity and it was only fired straight up in the air and came back down, it would still reach after 3 seconds 39.9. Even if the horizontal velocity was 100 meters per second or 1,000 or a million, it wouldn't make any difference. The object would still only travel to 39.9 meters after 3 seconds. So the horizontal, so as I said here, the horizontal and the vertical velocities are independent of each other.